Hello, we're going to be doing a lesson over polygons today, lesson 18.1. This is another review one, just like the ones from last week. So if you don't have it with you already, grab your math textbook, paper and pencil. That's all we'll be using for this lesson. No workbook pages for this lesson again. So pause this video if you don't have those things, and we are going to go over the different types of polygons. Now, as you can see here on page 303, that's where we're starting. There are two types of plane figures. Now, a plane figure, like an airplane, the way it's spelled, is two-dimensional or flat. So the group A over here is a grouping of open plane figures. That means that there is some sort of opening in each one of these figures. Okay, if you were on the outside of one of these figures trying to get in, there would be sort of like a gate entrance. Versus group B has plane figures that are all closed. This is the one that we'll be looking at specifically. Okay, so right here, let's just do together. Is this closed or open? Open. Closed. Open. Okay, now polygons are a special type of closed figure. A polygon is comprised of different line segments. Now, a line segment, as we know, just like a line, has to be straight. So this triangle is an example of a polygon. So is this rectangle and this hexagon. They all have straight lines, or actually they're line segments since they are cut off. Versus this group has several shapes with curves to them. If there is even one curved line, it is no longer considered a polygon. So this circle and this shape, they have only curved lines. Or this one in the middle, that's kind of like a rainbow. It is also a polygon because even though these are line segments, these are not line segments. Okay. Now, on the next page, we're on page 305 now. Which of these figures are polygons? Nope, it is an open figure. We're just going to draw a line through. Is this a polygon? Nope, it's not a polygon because it does not have straight line segments. Polygon? Yes. It's unusual, but this one is a polygon. Polygon? Nope, because it has an open space just like this. Polygon? Yes. And is this a polygon? Yes. Okay, this is a square, this is a rhombus. Okay, if you are able to do this Let's Explore section, that'd be great. Use craft sticks, which is kind of like a popsicle stick, and you can make some of the figures. Try using 2 sticks to form a figure, and you should be able to observe with that all you're going to be able to make is an angle with 2 line segments or 2 craft sticks. But with 3 or more, you'll see that there are some polygons that you can create. Okay, now moving on to the next page, it says identify special polygons and their names. Most polygons have a special name depending on how many sides there are. A side is the line segment on the outside of a polygon. So a triangle is the 3-sided polygon. There are several names for 4-sided polygons, which we call quadrilaterals. For example, a rectangle and square are 2 very common types of quadrilaterals that have 4 sides. Over here is a pentagon. That's the name for a 5-sided polygon. Hexagon has 6 sides, and octagon has 8 sides. Those are some of the common ones. Now, another term to review is basically kind of the opposite of angles. We discussed a few weeks ago that when 2 line segments come together, they form an angle. Okay, and we use a little arc to show where that angle is, to mark it. And you can see that right here in the drawing. Now, the vertex is what is on the outside. It's the point of any polygon. Okay, so if we turn this into a triangle, the vertex is the point of it. Now, the plural of vertex is vertices, so sometimes we'll say that. That's an unusual plural. It says this in the little speech bubble as well. Vertices is the plural for vertex. And once again, the side is that line segment from the outside. Okay, now let's identify the parts of this pentagon. Okay, this is a pentagon because it has 5 sides. What is this? We call that the side. We'll go ahead and write side there. And this is a vertex. Okay. Now count the number of vertices, and what do you get? 5. How many sides are there? Also 5. Usually it's going to be the same number. Count the number of angles on the inside. 5. Okay. Choose true or false for each statement. Does an octagon have 8 sides and 8 angles? Yep, true. Does a hexagon have 7 vertices and 6 sides? That is false. A hexagon has 6 vertices and 6 sides. They line up. They should be the same number. A square and a rectangle have 4 vertices and 4 angles each. True. That's right. Those are both quadrilaterals. They have 4 vertices and 4 angles. Do all polygons have 4 sides? False. All quadrilaterals have 4 sides, but polygons can have 3 or more sides. If it has less than 3, then it's no longer a polygon. It would just be an angle. Okay. For the hands-on activity, I do encourage you to do this. It says work in pairs. Some of you can do that with a sibling possibly. Other people will not be able to, but I encourage you to record some information in the table. This is the table below about some different polygons that we just looked over in the last couple pages. It says walk around your school or classroom. Your school or classroom now is your home. So try to find some triangles, squares, rectangles, pentagons, hexagons, and octagons around your home. Okay, now quadrilaterals, once again, have the most names. Quadrilateral is the name for any shape or any polygon that has 4 sides. But there are a lot of types of quadrilaterals. Okay, all of these are examples of quadrilaterals because they have 4 sides. They also have 4 angles and 4 vertices. Here are some common objects that would be considered quadrilaterals: a door, a book, a TV or computer monitor, a frame, and a kite. We have some specific names for each of those types of quadrilaterals, though. On the next page, page 310, it says choose the quadrilaterals. I want you to help me out with this. Is this a quadrilateral? Yes, we don't have a specific name for that kind of quadrilateral, but it is one because we can count the sides and angles and vertices to be 4 each. Is this? Yes. Quadrilateral? No. Is this a quadrilateral? No. This? No. This? Nope. This? Nope. That has 5 sides. It's a pentagon, even though it's an unusual shape. And this one, yes. Okay. Choose true or false for each of these statements. The outline of a ruler, is that a quadrilateral? Yeah. We'll put a T for true for that. Is the outline of a bottle cap a quadrilateral? I've never seen one that's a quadrilateral. Usually they're just a circle. So I'll put an F for false. The outline of a postcard? Yeah, that's a rectangle generally. And the outline of an envelope? Yeah, also a rectangle, which is a type of quadrilateral. Okay, now a quadrilateral can be classified by if the pairs of sides are parallel to each other. Remember, we just talked about parallel lines. 2 lines that are always the same distance apart. They never become closer or further away. They are always equal distance apart from each other. We can also classify some quadrilaterals by if the sides are of equal length and if the angles are right angles or not. So this is one category of quadrilaterals, okay? If the opposite sides are parallel, actually, we'll get to that later. Okay, so this shape here is a square. And in all of these areas, it actually is true that the square has two pairs of sides that are parallel. The sides are all of equal length all the way around, and all angles in the shape are right angles. And remember that a right angle means that the two line segments are perpendicular to each other. Now, here is figure B, a rectangle. Now, it is very similar to a square, except that two of the sides are different length than the other two sides, okay? So it does not go along with part B that the sides are of equal length. Okay, this is a parallelogram, and a parallelogram is actually a category of lots of the quadrilaterals, including a rectangle and a square. A parallelogram is a shape that has two sets of parallel lines. This one that you see in the book is an example of a parallelogram like this, okay? We can use our dotted line to show that if we have our lines go on and on forever, they still are the same distance apart from each other, both this way and this way, okay? Now, a rectangle is also true of this, though. As you can see here, the rectangle also has two sets of parallel lines. So does the square. So a parallelogram, generally you'll see it look like this. But a rectangle and a square are both also examples of parallelograms. Okay, so is a rhombus. That's our next one. A rhombus does have two sets of parallel lines. A rhombus also has all sides of equal length, but it does not need to have right angles. That's why a rhombus is different than a square. Square will have right angles. A rhombus doesn't need to have right angles. Okay, but that's the only difference. A square is just a special rhombus. Okay, these are some trapezoids. Now, a trapezoid has four sides, but it only has one pair of parallel lines. As you can see here, this on the horizontal lines are parallel to each other. These are not parallel to each other, though. In this trapezoid, once again, the horizontal ones are parallel to each other. These are not, though. This would eventually run into the other one. Most trapezoids we see look like this shape, but there can be right angles in a trapezoid. They just don't have to be right angles in a trapezoid. Okay, so trapezoid has one pair of parallel sides. They're not of equal length. There doesn't have to be a right angle, but there can be a right angle in a trapezoid. Okay, for the hands-on activity, most of you probably can't do this. This would be wonderful to do in the classroom because we do have Geo Boards, but probably the majority of you don't have these at home. But you could possibly have an alternative to this if you have like dot paper and create different shapes on that dot paper. I'll try to attach an example of that dot paper to your Google Classroom assignment if you'd like to print one of those up. Now, let's go down to our next page, which is page 313. Okay, it says identify each rhombus. Which of these are rhombuses? And the dot paper is going to help you with your measurement. As you can see here, 1, 2, 3, 4 is how many dots across this shape is, and 3 this way. So can it be a rhombus if the sides are not equal? Nope, not a rhombus. Is this a rhombus? Nope, not a rhombus. A rhombus needs to have two pairs of parallel sides. This only has one pair of parallel sides. Is this a rhombus? Yes. Figure C is a rhombus. Okay. Is this a rhombus? Nope. Nope. No. Okay. So the rhombus kind of looks like a diamond. It does have